Alright, so when we find slope, right, what's another word for slope? Rate of change, right? The rate at which something is changing. So when we were finding the derivative of something and that something represented some amount, right? What we were actually finding was the rate at which that amount was what? Was changing, yes? Okay, so let's say I give you an example and it says if water is being drained from a swimming pool and R of T represents the amount of water measured in cubic feet that is in the swimming pool at any given time. Okay, so R of T tells you how much water is where? In the pool or that has come out of the pool? In the pool, it just told you, right? That is in the swimming pool, right? Alright, cool. Measured in hours, the time is in hours. Okay, then R prime of T would represent what? Well, what R prime? R prime is a derivative. What do we just say a derivative represented? The rate at which the amount is changing. So what is the amount that we're talking about? The amount of cubic feet that is in the pool, right? Of water. So if I find R prime, it's telling me the rate at which the amount of water in the pool is changing, right? And at what kind of a rate should that water be changing? At a negative rate, because we know that the water is what? Being drained, right? So the amount of water in the pool should be decreasing. Very good. Are we okay? Alright. So if I find the derivative of R of T, I would get R prime of T. And what would the units of R prime of T be? So it would be cubic feet per what? Per hour, right? See that up there? It's kind of like related rates. It's a derivative, right? So we're finding a rate. Okay, we're just talking about what it means. That's all we're doing. So now look at the next one. If I were to get the integral from sometime to sometime of something that was a rate, then it should equal the amount of what? The amount of change, right? So remember we said right here, right? When I integrated this rate, which was R prime, okay, the rate at which the amount of water in the pool was changing, what would I end up with? The amount of change of what? What did that R function represent originally? The amount of water in the pool at any given time, right? So this is telling me the amount of change of the water that is where? In the pool, specifically in that time interval, okay? From A to B. Do we understand? Yes? Okay, so let's write that, because it's asking us to explain it. So this represents the amount of change in what? What do we say these values we're talking about right now? R represents the amount of water in the pool, okay? So it represents the amount of change, maybe instead of in, the amount of change of water, right? In the pool. Okay?
Yeah.
From where to where? From T equals A to T equals B hours, right? So it's kind of saying like the water at this time was this much, right? And then the water at this time was this much. So what you're calculating is the change in the water, right? How much water was in it. Okay, you could also say that you're talking about the change in the water what? The water level, right? You could also say that. Okay? That would also be a good justification. So basically what I want you to get from here is that when we find a derivative, we're finding the rate at which that amount is changing. But when we find the integral of something that represents the rate, we're finding the amount of change that is occurring. The amount of change of something. Do you understand? Yes? The change in something. That was the big idea. Here's the change in the amount of water, right? If this were velocity, then it would be the change in how'd it go? You didn't finish? Oh man. Good try. You put your names?
Yeah.
So it would represent the change. If it was velocity, what would it represent? If we had velocity here, what would we end up with over here?
Like number 2 by 1.
Position, right? So it would be the change in position in that time interval. If it was acceleration that you were integrating, then it would represent the change in velocity in that time interval. You understand? Yes?
Oh, like action.
Okay?
No, I didn't.
So let's do some practice problems, and we're going to practice how to write what it represents, because you will have to do those types of interpretations on the AP test. And you'll see some problems that are similar to it. They've been getting a little bit more and more complex. They start talking about, stuff going in the pool, stuff coming out of the pool, and then you have to take all those into consideration. You have to take into consideration how much was poured and how much left, to figure out how much water is in the pool at a particular moment in time. So that's kind of the problems that we're trying to lead to, but right now we're just getting our feet wet. Okay? So this table says it represents velocity of a particle, right? And t is in minutes, and the velocity is in feet per minute, okay? So something to take note of. What else could we tell by looking at the table and looking at these velocity values? They're always what? Huh? What can you tell me about all those velocity values? They're always positive, right? So that's the main thing to take into consideration, that they're always positive. So we know that if velocity is always positive, what's true? What two things are equal to each other? Total distance and displacement. Come on guys, go, wake up. Okay, first question says approximate the value of the integral from 0 to 30 of v of t using a midpoint Riemann sum. Okay, using correct units of measure, explain what this represents. Right, so did they give us a specific number of intervals to create? No, so you don't know, right? So can you just make up whatever intervals you want? Yeah, right, so since no specific set of intervals were defined, you can make up your own. So from where to where do you want to go? From 0 to 10 would be a good one. 10 to 20 would be good. 20 to 30. Now why would I pick those? Because that gives me something in the middle, right, that I can use. Right? Okay, so what would be the difference from 0 to 10? 10, 10 to 20? 20 to 30? So are they all the same amount? Yes?
Yes.
Alright, so that should make this Riemann sum easy to calculate. So if I do the integral from 0 to 30 of v of t dt, that should approximately be, not equals because we're doing a Riemann sum, and what would I write? 10 times 1.6, because that's the midpoint, plus 3.1, because that's the next midpoint, plus 1.6. If they said left Riemann sum, then I would use 0, 1.6, 2.7, so on and so forth. Or actually no, 0, 2.7, and 2.4, because there's only 3 subintervals. What would we get here? $63? That means type it in your calculator. Don't wait for other people to type it in and spit out the answer. Good? Alright, so now we need to answer using correct units what this explains in the context of the problem. What it means. Why did I put feet here? Because if I integrate velocity, I get position, right? Well, I should end up with something that's only feet, right?
Yeah.
Okay, so what could we say this represents? I'll get you started. This represents the total distance, the displacement, or both? Why both? Because velocity is greater than 0?
Yeah.
Okay,
In which case we can just use this.
yeah. Well, would all of those be correct?
Yeah.
Could we also say that this represents the amount of change in position, right?
Equals 0
From 0 to 30?
to, yeah.
Okay, cool. So what do you want me to write?
You pick one, so
All of them? Alright, so this represents, right? I'm gonna say the approximate amount of change in position. And I always like to include the units that it would be in, so in feet, right? From t equals 0 to t equals 30, and that was, I think, in what? Minutes. Okay? We could also say, since v of t is greater than 0 on that interval 0 to 30, and I said open interval because at 0 and at 30 it's equal to 0. Okay? If it were positive there, then I would put the brackets. Good? We could also say what? This represents, right? The total distance traveled by the particle in feet from t equals 0 to t equals 30 minutes. Could have said that without saying this represents the displacement, right? Instead of traveled by the particle, the displacement of the particle, right? In feet from t equals 0 to t equals 30 minutes. All of those would be considered correct answers. All 3 of those, okay? Pretty good? It's gonna take practice, okay? Main thing to get is that when you integrate, you're finding the amount of change in something. Alright, part B. What is the value of the integral from 5 to 25 of a of t? Then, using correct units, explain what this value represents. So, what would the integral of a of t from 5 to 25 give me? What should it spit out?
V of 25.
V of 25, good job, Oscar, minus
V of 5.
V of 5. So it's giving me the amount of change in or of velocity, right? Okay, so what's V of 25? Do we have that? And what's V of 5? So what does that give us? 0, right? And what would the units of that be? Feet per minute, why is it feet per minute and not just feet here? Right, because we're talking about numbers that represent velocity. Cool? Alright, let me get you started. This represents what? The amount of change of velocity, right? In what units? Feet per minute from t equals 5 to t equals 25 minutes. Getting the hang of how to write the statements?
Yeah.
Yes? And I'm just training you to do it like this to make sure that you get the full credit. It's not necessarily that it has to be written exactly like this, but you have to say what I'm saying in this statement. You understand? Yeah? Let's try this next one together and see what you got. What is this one describing? Temperature of water in a tub at time t is modeled by a strictly increasing and twice differentiable function w, where w of t is measured in degrees Fahrenheit and t is measured in minutes. So is this a rate? Does w represent a rate, or does w just represent an amount? It's an amount, right? Okay, it's the degrees Fahrenheit at that particular moment in time. So when I turn on the water,